All right, so now we're on the second page of the group work. This is the word problems that we're going to work through. And the word problems, the word problem formulas are going to be provided to you, like A equals P times e to the RT, A equals P times 1 plus R over N to the N times T, and probably the half-life formula, A is equal to P times 1/2 to the power of T over H. You just need to know what the variables mean, but I'll show you how each one of these formulas help us out to solve these pretty easily. All right, so let's start off with the first problem, number 11. John is looking to buy a car on his 16th birthday. If his parents invested $3,000, so that's how much he started off with, in his savings account on the day he was born, so now he's 16, so that's been 16 years, at 7.5%, which is the same as 0.075 for our R. Now it's compounded continuously. That's what I was looking for. When it's compounded continuously or any type of continuous growth like population growth or anything like that, we would want to use the PERT formula, the compound continuously formula, to solve. So we're going to use that pretty regularly in most contexts. So for this one, we were told, basically how much money he's going to get, and then we need to kind of like figure out how much more he's going to need to get to $12,000. So let's figure out how much he has in his savings account. So the savings account is going to be equal to the amount that he started with, which is 3,000, times e to the power of R, which is 0.075, times the amount of time that's passed, which is 16 years, because he just turned 16 when he's going to buy his car. So, type that in your calculator, and you get some amount. So let's see what that's going to be. 3,000 times parentheses. Oops, we don't need the times parentheses. So 3,000 times e to the power of 0.075 times 16, and you get $9,960.35, and it's an approximate amount. Now, let's figure out how much John's gonna need to save after that. So he has $12,000 that he needs. He has $9,960.35. So if we subtract that amount from the 12,000, we'll see how much he needs to save up after that. So 12,000 minus that number that we just had, and we get $2,039.65. So that's how much he needs to save up, $2,039.65. Don't forget the units on that, dollars. And that's number 11. Number 12 now. Find the following information for an investment compounded monthly. Okay, so compounded monthly means that we're going to be using the compound interest formula, and monthly actually even tells us the n value there, n equals 12. If the amount after 15 years, so that's the amount of time, is 25,000, that's the amount after that time, so that's A. And the interest rate is 7.5%, so that means that R is equal to 0.075. Find the initial investment, okay, because that's the only variable that we don't have, P, so that's what we're looking for. So for the formula, A is the end amount, so that's $25,000. That's equal to P, which we're trying to solve, times 1 plus R, which is 0.075, over n, which is 12, to the power of n, 12, times the amount of time that's passed, which is 15 years. So we're going to use this pretty regularly because it looks like we're just using the same values over and over again for the interest rates and everything. So let's just figure out what that is real quick on our calculator. So we do 1 plus 0.075 divided by 12, and that's 1.00625. So we're going to use that pretty regularly, so let's just remember that that's what that equals. So P times parentheses 1.00625 to the power of 12 times 15. And I mean, it even helps you out in realizing that it's just a number that this base is. It's just an exponent. So we need to get P by itself. So let's figure out what this whole number is right here. So we do 1.00625 to the power of 12 times 15, which is 180. And we get 3.069 something or another. So that means that now 25,000 is equal to P times whatever that is. So 3.0695. Let's just go to 4 decimal places to be safe. All right, now let's get the P value by itself. So we divide both sides by 3.0695, and we find out our P value. It's approximately equal to what? So 25,000 divided by that number that we just had, and we get $8,144, and you can round that up to 78 or put 77. It doesn't really matter. We're probably going to keep it about the same. So, we're probably going to be pretty lenient about that. So let's just say that it's 8,144.77, just because it'll maybe be like a fraction easier to type in. Okay, so let's find the amount of money now that we have the initial amount that he's going to have after 7 years. So A is equal to the amount that he started with, 8,144.77, times 1 plus 0.075 over 12, which is that same number that we had, 1.00625, to the power of 12 times, now it's 7 for a time, so times 7. All right, so we can just type that all into the calculator at once and figure out what that amount is going to be. So 8144.77 times 1.00625 to the power of 12 times 7. And you end up with about $13,745.92. So this is the answer for part B. This is the answer for part A. Now let's do part C. The time that it takes to triple the investment. So if you've done the word problems in the previous worksheet, you'd know that for this problem, you just need to set it up with 3 is equal to the exponent. So 3 is equal to the base 1.00625 to the power of 12 times t. Then we solve for t. If you didn't know that, basically you can multiply this by 3. You get like 24,000 something and set that equal to the a value. But when you divide by 8144.77, you end up with 3 anyways. So you're going to end up with this at any point. So, just start off there. Now that we have an exponent equal to a number, we're going to just convert it to a log, just like what we did on the previous page, just converting from an exponent over to a log. So we get log with a base of 1.00625 of the number 3 is equal to 12t. So since this is a word problem, we don't need to find exact numbers. We just need to find approximate numbers. So let's figure out what that's going to be. So we get log, let's do the log base thing. So math, and then log base, there we go. So log base 1.00625 of 3 equals that number. So 176.33 is equal to 12t. Divide both sides by 12, and you get your answer for t. T is equal to about 14.7 years. And we might ask you to round it to the nearest year or something like that. Just make sure you read the directions. This one doesn't say to do that, so I'm just kind of estimating. 13 and 14 can be handled very similarly. The bacteria population found in a common case of strep throat has a half-life of 4 hours after taking antibiotics. If the initial culture indicates, it says half-life right here, so that means we can use the half-life formula for this one. So let's, use it. A equals P times 1/2 to the power of T over H, where H is the amount of time it takes to get to a half, in other words, the half-life. 4 hours is our half-life, so that's the H value after taking antibiotics. The initial culture is 1.2 million, so that's the initial amount, P. How many bacteria are left after 50 hours? So that's T, and we're supposed to solve for the A amount. So A is equal to 1.2 million, so 1,200,000. And then times e to the power, not e, I'm doing it the PERT method. So this is another way to solve it, but let's do it with the half-life. So times 1/2 to the power of t, which is 50, over h, which is 4. And then, type it in your calculator and just get the a value. So we have 1,200,000 times 1/2 to the power of 50 over 4. And then you get right around about 207.16. Let's say 207 bacteria. That would be your answer there. All right, and that's it. That's all that they're looking for. Okay, next let's go over to number 14. So find the initial population of a species of whales is, the initial population of a species of whales is 2,000, so that's the initial amount, P. If the population doubles every 6 years, then when will the population be 150,000? So that's like the A amount essentially. So here's where you can use the template of half-life in a different method for solving, because if you know it's a continuous growth thing like population is, you can use this idea, but instead of half-life, halving something, we're doubling something, so we're going to change that base just to a 2. So we'll probably give you this formula on the board or on the test, where it's just the half-life formula. So you can know how to use the doubling formula just by plugging in 2 instead of a half. So this is how you can put together the formula. It's the area in the, it's not the area. The amount that you have after the amount of time t is equal to the amount that you start with. And then if you're doubling, that base becomes a 2. That's it. And then to the power of t over the amount of time it takes to double. It's the same type of problem, and it works every time if you need to do doubling or tripling with exponential growth. So if our initial population of whales is 2,000, 2,000 goes there, and then times 2 to the power of t, which is, let's see, we don't know, we're solving for t, over the amount of time it takes to double, which is 6 years, and that equals 150,000. So we just solve for t. Isolate the exponent, so divide both sides by 2,000. So we get 75 is equal to 2 to the power of t over 6. And then convert it to, since it's an exponent equals a number, convert it to a log. So we have log base 2 of 75 is equal to t over 6. And then, to get t by itself, you just multiply both sides by 6. So t is equal to 6 times the log base 2 of 75. And then it's calculator time. So let's figure out how many years that's going to take. So 6 times log base 2 of 75. And that gives you about 37.37 years. So that's going to take a while to double the population of those whales. Hopefully they make it. All right, so that's all of the problems for the group work. I'm going to throw in, because I have a couple extra minutes before the 15-minute mark, an extra bonus word problem for you. So number 12 off of the extra review that you guys have. And you have all the answers for them as well, but I thought I'd go through this problem just because I think it's kind of important and neat, because we didn't have any logistic problems on the group work. Maybe it might be helpful to go over one in preparing for the test. So it says in typing class, the average number of words per minute n typed after t weeks of school was found with this. At time t in weeks, did the class average typing speed equal 75 words per minute? So in other words, they want us to figure out when n is equal to 75. So this kind of creates something that maybe can be kind of difficult for some of you guys, and that's that we're solving this logistic problem. It looks intimidating. 75 is equal to 157 over 1 plus 5.4 e to the power of negative 0.12t, but it's actually solved the same way that we did any of these other problems in the examples where x is in the denominator. We're trying to solve for this variable, it's in the denominator, so we just turn this into a fraction and then cross multiply. So if we cross multiply, we get 1 times 157, so 157 is equal to, and then 75 times all of that stuff down there, 1 plus 5.4 e to the negative 0.12t. And then divide both sides by 75, so you get 157 over 75. I'm going to be very reluctant to type stuff into my calculator yet, just because I want to mess around with the numbers and see what I get. So that's equal to 1 plus 5.4 e to the negative 0.12t. All right, so then I'm going to subtract 1 from both sides. All right, let's just use the calculator. Let's make this go a little faster. Plus, this is probably what you guys are going to end up doing anyway. So it's 157 divided by 75, and then minus 1, because we subtract 1 from both sides. So we end up with that decimal, and of course you can turn it to a fraction by hitting math, and then change it to a fraction. So that's going to be 82 over 75. So now 82 over 75 is equal to 5.4 e to the negative 0.12t. We want to isolate the exponent, so we need to divide both sides by 5.4 now as well. Oh boy, how's that one going to look? So we take that number and divide it by 5.4. Get another decimal answer. Let's convert that to a fraction as well. What do we get there? 82 over 405. Oh my. And that's equal to e to the power of negative 0.12t. Now we solve for this exponent, which is exponent equals a number, by converting it to a log. So we have log base e of that fraction, 82 over 405. And let's call it what it is, log base e. We know for a fact that that's just the same as saying natural log. So I'm going to erase that and just write natural log on there instead. Okay, so that equals the power, negative 0.12t. So now to get t by itself, we just divide by that, and let's see what we get. So t is equal to natural log of 82 over 405, and then that whole number divided by negative 0.12. Let's see what we get on our calculator. It's probably going to be an approximate number, but let's figure out how many weeks this is going to be. So natural log of 82 over 405 divided by negative 0.12. So it's going to be about 13.3 weeks. All right, so I wonder why I would go over a logistic problem with you on this review. Well, I guess we'll have to find out on test day, won't we? So good luck on the test. If you need some help, reach out to your teacher. Have a wonderful day and make sure to, enjoy going over these problems. Bye-bye.